Hi everyone, my name is Marcia, and today I want to talk about the SIR model and how we can represent it as a continuous time Markov process. The SIR model is used to predict the spread of a contagious disease within a closed population. Let's say that we have a population N, and we separate those N people into three different groups: susceptible, infected, and recovered. When we add the number of people in each group, it should sum up to N. Susceptible represents people who have never gotten this disease and have not received the vaccine. In other words, they can be infected. Infected are the group of people who are carrying this disease. Recovered are people who have recovered or unfortunately passed away because of this disease. People of this population are transiting from susceptible to infected, from infected to recovered. Then, here comes a question. Can we define an appropriate continuous time Markov chain for this population? If we can, how's the Markov chain going to look like? First, let's define the states. At this moment, in this population, there are X people in the group susceptible, Y people in infected, and Z people in recovered. X, Y, Z should sum up to N. We can represent this current state as X, Y, Z. So where is this state going to transit to at the next instant? Well, there are two possibilities. One is that one person in the susceptible group got infected, which can be represented as X minus 1, Y plus 1, Z. Or one person in the infected group is recovered or passed away, which can be represented as X, Y minus 1, Z plus 1. We can treat any moment in this Markov chain as the current moment. In other words, all the states can be represented as X, Y, Z. The value of X, Y, Z can be any integers from 0 to N. The absorbing state of this Markov chain is when Y equals to 0, which means no one in this population is carrying this disease anymore. Next, let's define Qij, the rate of transition. Let's say that the rate of transition between those two states is alpha, and that alpha should not be a constant. Let's think about this for a moment. In a population, the rate that the susceptible become infected should depend on the amount of interaction between those two groups. If we increase either ST or IT, that will increase the amount of interaction, which leads to an increase in the rate of people getting infected. Thus, alpha should be a variable that relates to both ST and IT. How about the rate of transition between those two states? Let's say it's beta. And beta should only depend on IT. As the amount of infected people increases, the rate of people going from infected group to recovered group should also increase. So this is how we can represent a basic SIR model as a continuous time Markov chain. There are definitely much more to it. As COVID-19 is now spreading around the world, many mathematicians are trying to use mathematical models such as the SIR model to predict the spreading of this terrible disease. Hopefully my video gives you an insight into the SIR model. Please stay safe and take care of yourself during this special time. Thanks for watching.